6 and pi over 4, which is 45. So now we're going to introduce, have you guys learned about x, y, and r last year? Okay, so basically x would be your adjacent side, y is going to be your opposite side, and r is your hypotenuse or radius. So if p, x, y is any points on a circle of radius r, and also the terminal arm of an angle in standard position, then the trigonometric ratios are. So I'm going to just complete this triangle. So this is your x, and this is also your y. And our reference angle is going to be theta. Okay? So again, sine is opposite over hypotenuse, so y over r. Cosine adjacent over hypotenuse, which in this case is x divided by r. And tan is opposite over adjacent, which is y over x. And the reciprocal functions is just the parent function, and the ratio is just flipped. Okay? So people seem to mix these two up because people think sine it goes in hand with secant, but it's just the opposite letter. So remember, sine goes with cosecant and cosine goes with secant. Okay, and then tan is just cotangent because it's in the name. Okay, and because it creates a right angle triangle, we can say that x squared plus y squared is equal to r squared, where r is bigger than 0. So remember, you guys probably remember this, right? Power over 4, power over 3, power over 6. So remember, power over 4 is how many degrees? You guys remember?
30.
No, power over 4.
45.
45. What is power over 6? 30. And what is power over 3? 60 degrees. So you guys probably made a whole chart last year. We're going to make another chart this year. So we want to use these triangles to determine the trig ratios of the following angles. Okay? So if we look at the first one we're going to look at is the special triangle pi over 4. So if we take sine of pi over 4, what ratio do we get? Opposite over hypotenuse. And let's just reference this angle. So this is opposite, adjacent, and hypotenuse. So what would our trig ratio be for sine of pi over 4?
Root 2.
Okay, 1 over root 2. Or because root shouldn't be in the denominator, what does it change to?
Root 2 over 2.
Root 2 over 2. Do you guys remember the word your teacher used when you multiply something by itself, like root 2 over root 2? Because I forget the name of it. That's going to bother me. It's not the conjugate, no. Is it? Is that word ring a bell? I don't think it's conjugate. It sounds too much of an English word to be used as a math word. Okay, so the next one we have is cosine of pi over 4. So we have adjacent over hypotenuse. So what ratio would we get? So the same thing. 1 over root 2 or root 2 over 2. And last but not least, tan of pi over 4, so opposite over adjacent. What ratio do we get? 1. All right. And now we're going to look at the reciprocal functions. So if sine of pi over 4 is 1 over root 2, what does cosecant of pi over 4 give us? Root 2. Which means it's the same thing for secant, and tan is just 1. So pi over 4 is the easiest one out of the two special triangles. And next, we're going to look at sine of pi over 3. So remember, we're using this angle over here, which means root 3 is our opposite side, 1 is our adjacent side, and 2 is our hypotenuse side, or this is, no, I can't do that yet, not x, y, and r. So what is sine of pi over 3? Opposite over hypotenuse.
Root 3 over 2.
So root 3 over 2. What is cosine of pi over 3? 1 over 2. And tan of pi over 3? Root 3. All right. So now for the reciprocal functions, we need to take the reciprocal of each one. So if sine of pi over 3 is root 3 over 2, what does cosecant give us? So just flip it first and then we'll simplify it.
2 over root 3.
Or if we multiply numerator and denominator by root 3,
2 root 3 over
2 root 3 over 3. Okay, and how about secant? What is the reciprocal of 1 over 2? So 2. And how about for root 3, for 10?
root 3 over 3.
So root 3 over 3. So it's 1 over root 3 or root 3 over 3. Okay. And last but not least, we have our pi over 6. So now our angle of reference is going to change to here. So this is our opposite, this is our adjacent, and this is still our hypotenuse. So what is the ratio of sine pi over 6?
1 over 2.
1 over 2. The ratio for cosine pi over 6? Root 3 over 2. And the ratio for tan of pi over 6? Root 3 over 3. Okay?
Isn't that 1 over root 3?
But when you
Yeah, when you simplify it, you get root 3 over 3.
Oh, yeah.
Or, okay. So what's the reciprocal of cosecant?
2.
Secant?
2 root 3 over 3.
Yeah. And how about for cotangent?
Root 3.
Just root 3. Okay. So those are the exact, so this is going to be very beneficial for when we learn about the unit circle. Okay. So what we're going to do next is we're going to learn how to solve for terminal arms and the primary angle theta and the acute angle beta. Okay. So there's no specific choice for those Greek letters. They just always use them in math. So the trig ratios for any principal angle theta in standard position can be determined by finding the related acute angle beta using coordinates of any point that lie on the terminal arm of the angle. Okay. So did you guys use the CAST rule last year? Okay. CAST,
Oh, yeah.
right? So what does the C stand for? Think of the trig ratios. So cosine. So what does that mean about the cosine ratio in quadrant 1? Positive. What does the A stand for? All, which means all trig ratios are positive. What does the S stand for? Which means sine is only positive in this quadrant. And the last one is tan, which means tan is positive in that quadrant only. So remember, this is quadrant 1, 2, 3, and 4. Okay? So just remember that information when we do our problem solving, okay? You always want to use the ratio that gives a positive value in that specific quadrant, okay? So what they mean by a terminal arm and an acute angle is this. So let's just say we have this given to us, okay? From quadrant 1 all the way to the terminal arm, that is going to be our angle of theta. And the acute angle that is formed inside, that is going to be referred to as beta. Okay? So those are two things you need to know now that we're going to sketch some of these problems out. Okay? So for example 1, we want to sketch each angle, determine the value of r, so the hypotenuse, determine the primary trig ratios for the angle, and we also want to calculate the radian measure of each angle from theta is between 0 and 2 pi. Okay, so if we just take root 3, negative root 3, and 1 as just a coordinate, so we have our x and our y coordinates, okay? So what quadrant is negative root 3 and negative root 1 going to lie in? In quadrant 3. So here we have negative root 3, okay? And we have, let's just say negative 1 is over here. Okay, so that is how you would draw that specific shape. So we have our related acute angle beta on the inside, but we also have our terminal arm on the outside over here.
Was that also a time clock?
So just on a side note, to calculate theta, if theta is in quadrant 1, why is this thing so uncalibrated here? So this is just a side note. So hopefully there's room to, I'll just make a new page. So if our point theta is just equal to beta. And what I mean by that is that if we have our point in quadrant 1, okay, there's no real terminal arm. It's just going to be the acute angle, so therefore theta is equal to beta. Now, if point is in Q2, then to find theta is equal to pi minus beta, okay? And what I mean by that is if our point is in quadrant 2, this is our acute angle over here. This is our terminal arm. So to find theta, all we're doing is taking pi, because from quadrant 1 to quadrant 2 is just 180, okay? And subtracting from the acute angle to get that big obtuse angle. So how about if my point's in Q3? How do you think I'm going to find that terminal arm?
Theta.
Yep. Or theta is equal to pi plus beta. And if we continue the pattern, if our point lies in the last quadrant, how do we find our theta? What would be the easiest way to do it? Think about the concept if it was in quadrant 2.
Pi minus beta.
Not just pi, but how many pi's? If we're in quadrant 4, we're almost making a full circle. So it's going to be 2 pi minus theta. So these are the ways in how you would calculate theta, given if the point is in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. So now we're going to circle back to our example here. So before we get into that, we need to determine the value of r. So how do we determine the hypotenuse of a right angle triangle? So in this case, it's r squared is equal to x squared plus y squared. Our r is negative root 3 squared plus negative 1 squared. And when we simplify that, what does it give us? So 4. So which means r is 2. Okay. So now we have our r is equal to 2. So this was our I we sketched. This is our second part. And then the last part, the second last part, we need to determine the primary trig ratios for the triangle made. So we know our x is negative root 3, our y is negative 1, and our r is positive 2. So what would our trig ratio be?
So you
Each
have
one.
to do for all 6.
The primary, yeah, you can do cosecant. Well, when it talks about primary, it's just cosine, sine of 10. So what does sine beta equal?
Negative 1 over 2.
Cos beta?
Negative root 3 over 2.
Okay. And 10
Root 3 over 3.
roots 3 over 3. All right, perfect. And now what's left to do is to calculate our beta and our theta. Okay, because it's in quadrant 3, what trig ratio is positive? So we're going to focus on tan. Okay, so if tan beta is equal to root 3 over 3, using your special triangle chart, what angle is tan at root 3 over 3?
Thirty.
30, so that would be pi over 6. So we have our beta given, okay, at pi over 6, because that's where tan is equal to root 3 over 3. Now to find our theta, because it's in quadrant 3, what are we using? Pi plus beta or pi minus beta? And do pi plus beta, which is equal to pi plus pi over 6. And when we simplify that, what would our terminal arms angle give us? What is pi plus pi over 6?
7 pi over 6.
7 pi over 6. So therefore, beta, which is the acute angle, is equal to pi over 6. And theta is equal to 7 pi over 6. For example, if that point was in quadrant 2, what trig ratio would I be focusing on? Sine. And if it was in quadrant 4?
Sine.
Cos. And if it's in quadrant 1, it doesn't matter because everything's going to give you a positive trig value. Okay, so beta is pi over 6. So you can either do tan inverse of root 3 over 3 on your calculator, but you have to change it into degrees. Or you would look at your special triangle chart and find where tan is equal to root 3 over 3. That's how we found out beta was pi over 6. But because we're doing it in radians, you would just keep it in radians, and it would just give you a decimal if it wasn't an exact special triangle angle. So I'll do that next part for example B, and that will give us a scenario where that is the cause. All right, so we're going to move on to example B. So for example B, we have the point 9 and negative 12. So in what quadrant is this point or terminal arm going to land in? So x is positive, y is negative.
Oh, 4.
Quadrant 4. So we have 9 over here and negative 12 over here. So our terminal arm would land in quadrant 4. Okay? So you have beta on the inside. And our theta is going to be on the outside over here. So now that we have our point, 9 and negative 12, how are we going to determine the value of r again? So r squared is equal to x squared plus y squared. Our x is 9 and our y is negative 12. And when we simplify that, what does it give us?
15.
Which is 225 and then square roots. And r is 15. So r is equal to 15. Okay? And now we want to determine our primary trig ratios. Okay, so again, we have our primary trig ratios. We have sine, cos, and tan beta. And we have our x is 9, our y is negative 12, and our r is 15 from what we found. So in simplest form, okay, what would sine beta be?
3 over 5.
For, because it's negative 12 over 15, so 4 over 5. Yeah. Negative 4 over 5, right? How about cos beta?
3 over 5.
3 over 5. And tan beta?
Negative 4 over 3.
Over 3. Okay? So now we have our primary trig ratios. So what quadrant is the terminal arm in?
4.
4? Which means what trig ratio is positive in quadrant 4?
Cosine.
Cosine. Cosine is positive. Okay? So what is the ratio for our cosine? Based off what we wrote? 3 over 5. So a cos beta is equal to 3 over 5 beta. So even though you would use the inverse to find the actual angle, keep your calculator in radians, because when you do the inverse, it'll give you the amount of radians it's supposed to be. So we do cos inverse of 3 over 5. So what is the cos inverse of 3 over 5 in radians?
0.93.
Is equal to 0 points.
93.
That's an approximation, okay? So our beta is equal to 0.93 radians, okay? So you have that part done. Now we need to figure out what theta is. So if we're in quadrant 4, how do we figure out the measurement of our terminal arm theta?
2 plus beta.
2 plus or
2 pi.
minus? Right, because we just want that terminal arm, we don't want the acute angle included. Because if we do 2 pi plus, it would give us an angle bigger than 360.
So how do you draw it? You put the connected to the top line or the side?
Okay.
So how can you do that, like,
Which
draw
one?
the, oh, okay, never mind.
Because if we draw it connecting to
Yeah, I
the
know,
y-axis,
then the angle goes.
the angle is gonna be over here.
Yeah,
And we always want the angle to be contained within the x and the y. So we get 2 pi plus beta, so 2 pi minus 0.93. Now we just need to convert pi into its radian number. So what is 2 pi minus 0.93?
5.35, 5.4.
Approximately 5.35. So when it comes to these types of questions, like what's the two most important things you need to do before solving for your terminal arm? What two things did I tell you guys to focus on?
the quadrant.
The quadrant it's in and
uh,
what trig ratio to use in that quadrant, okay? So you're never gonna be using the other trig ratios. If it's in quadrant 4, you use cosine. If it's in quadrant 2, you use sine. If it's in quadrant 3, you look for the tan ratio. You always want to make it easier for yourself and look for the things that give you a positive number. Okay? So hopefully, is this terrible? Or do you guys think you guys are going to need like just more practice to get the hang of it?
yeah.
Okay. And last but not least, we have our last example. So we have given sine theta is -5/8, where 0 is less than or equal to theta and less than or equal to 2 pi, sorry. For A, in which quadrants could the terminal arm of theta lie? So let's answer question A. So when we're given our sine ratio, what two parts of x, y, and r are we given?
Opposite, which is
Y and R.
Y over r. So based off the fact that we have y as -5 and r as 8, where can this possibly lie? In what quadrants?
Oh, no, that's
And-
not right.
Quadrants. There's two possible answers. Yeah, so in 3 and 4, because that's where the y's are negative. Okay? So we can have one over here. Or we can have one in quadrant 4. Okay, so this is going to be our beta for one, and this is going to be our beta for the other. We have our r is 8 on both, and our y is -5. So there are two terminal arms we need to find, okay? So where does the first triangle land in? 3. So quadrant 3, which implies if we want to find theta, tan is positive. So this is T and this is C. So if you want to find the terminal arm in quadrant 3, what are we going to subtract or add? And if we have it in quadrant 4, which is the next case, what are we using? Theta is equal to
2 pi minus beta.
minus beta, which is the acute angle. Okay? So for A, we determine it can be in Q3 and Q4. So Adam, this is where you have to find cosecant, secant, and cotangent, because what does question B ask? Not the primary, but all of them. Okay? But before we can even find the trig ratios, what are we missing from our we're missing x? Okay? So x squared is equal to r squared minus y squared. So we get x squared is equal to 8 squared minus negative 5 squared. And when we simplify that, what does it give us? I know it's not a perfect value.
39.
Okay, so x is going to be positive and negative 39. Okay, so let's just do it for quadrant 3. So we have, would our x value be positive or negative in quadrant 3? Negative. So you have x is equal to negative root 39, y is equal to negative 5, and r is equal to 8. In quadrant 4, what is my x value, positive or negative? In Q4.
Positive.
It's going to be positive, so you get x is equal to positive root 39, y is equal to negative 5, and r is equal to 8. Okay, so let's just do it for one of the quadrants. So let's find all the primary and secondary trig ratios for quadrant 3. So we have sine beta, cos beta, tan beta, and then we have cosecant beta, secant beta, and cotangent beta. So based off quadrant 3, what does sine equal?
Negative 5 over 8.
So negative 5 over 8, which is what we're given. And what is cosecant then? 8 over negative 5. All right. And now what is the ratio for cosine? Remember, cosine is x over r.
Negative root 39 over 8.
Okay. Negative root 39 over 8. And what would secant be then?
8 root 39 over 39.
Positive or negative?
Oh, no, sorry.
Negative,
8,
right?
8 root 39 over 39.
Okay. And last but not least, what would tan be?
Negative 5 over negative root 39.
Okay. And when we want the roots on top?
Negative 5 root 39 over
Mhm.
39.
And because we have two negatives dividing each other, we can leave it as positive, okay? Which means our cotangent is just root 39 over 5. Okay? So now we have our starting points to solve for beta and theta. Okay, so now for C, it is asking state all possible radian values of theta to the nearest hundredth. Okay? So if we start off in quadrant 3, we said tan is positive. Okay? So in radians, If we take the inverse of 10 beta, what does beta give us?
0.68.
0.68. So we have our first part, which is beta is equal to 0.68. And because it's in quadrant 3, theta is equal to pi plus beta. So it's equal to pi plus 0.68. And what would theta give us in quadrant 3?
2.82.
3.82. Perfect. And because we have the same numbers, what do you think the acute angle is going to be in quadrant 4? Is it going to be different or the same?
The same.
Should be the same.
Like, do you have to then, like, you have to do all the, I guess it says determine all the exact values for quadrant 4?
So because it says determine all,
Yeah.
because there's 2 possible locations where that terminal angle can land, you have to do it for quadrant 3 and quadrant 4. So quadrant 3 or quadrant 4, we know beta is equal to 0.68 based off our previous answer. And because it's in quadrant 4, theta is equal to 2 pi minus beta, which is equal to 2 pi minus 0.68.
Right, so if it's quadrant 4, would you have to use cos?
Yeah, but because we have the same numbers,
Yeah, it is.
cos, sine, and tangent still give you the same angle or the same radians, right? So for example, if for the special triangles, right? For even though tan, cosine, and sine have different ratios, they're still going to give you back the same angle, correct? It's the same idea with this. Even though it's in quadrant 4, the acute angle is still the same for both of them. So theta is equal to 2 pi minus 0.68. If we simplify that, 5.6 radians. So, therefore, the possible radian values for theta are 3.82 radians and 5.61 radians. Okay, so cohort B and C, are you guys understanding this? Okay, Yusuf, I'll help you out on Friday, in person.